Here we're going to solve 3 resistors in parallel circuit of 3 resistors in parallel. We have R1 10 kilo ohm, R2 is 2 kilo ohm, and R3 is 1 kilo ohm. First, we're going to solve R total. So, this is the formula. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over 10 kilo plus 1 over 2k plus 1 over 1k. To convert the k or the kilo, we multiply by 10 to the power of 3. So 1 over 2 times 10 to the power of 3 plus 1 over 1 times 10 to the power of 3. So 10,000 1 over 2,000 1 over 1,000. A common mistake here is that some students may just add 1 plus 1 plus 1 and 10,000 plus 2,000 plus 1,000. This can't happen. Simply use the calculator. So 1 over R total is equal to, use the calculator here, 1 over 10,000 plus 1 over 2,000 1 over 1,000. This is 1 over 6 to 5. This is 1 over R total. This is not R total. The final step is to find R total. How can we find R total? Take the inverse of this number. So it's 1 divided by answer. You can find it in any calculator. 1 divided by answer equal 625 ohms. This is R total. So it's 625 ohms. The next step is to find V1, V2, and V3. In a parallel circuit, all branches. Again, when we get 1 over R total is equal to 1 over 625, this is not R total. To get R total, take the inverse. How can we get the inverse? It's 1 divided by answer is equal to 625 ohm. We wrote it here in the table. Next step is to find V1, V2, V3. The voltage across this resistor, the voltage across this one, and the voltage across this branch. In parallel circuit, all branches will have the same voltage drop, which is the same voltage of the voltage source or the power source. So all branches will have the same voltage drop. 9 volt, 9 volt, 9 volt. So V1 is equal to V2 and is equal to V3 is equal to 9 volt. Next step is to find the current that runs through each of the resistors. I1 is equal to V1 over R1. Okay? So 9 volt over 10k. Use the calculator. So 9 divided by 10,000. This is 900 multiplied by 10 to the power of minus 6, which is equal to 0.9 milliampere. For I2 is equal V2 divided by R2. All two, the same resistor, the same voltage and the same current. 9V over 2 kilo ohm. So here, divided by 2000, 4.5. We got here 4.5 times 10 to the power of minus 3. 10 to the power of minus 3 is milli. So 4.5 milliampere. Last current I3 V3 divided by R3, 9 volt divided by 1K. Which is 9 multiplied by 10 to the power of minus. Again, we divide 9 divided by 1000. 9 multiplied by 10 to the power of minus 3. 9 milliampere. So here we have 0.9 milli, 4.5 milliampere, and 9 milliampere. I total is the current that goes out of the power source or the voltage source, and it's divided across all the branches. So when the current reaches at this node, it will be divided to each one of these branches. Here is I1, here is I2, and here is I3. So simply we can just add the three resistors, or the three currents that runs through the three branches. So I total is equal to I1 plus I2 plus I3. Add them 0.9. So here we added the three currents of that runs through the three resistors, and we got the total current 14.4, and don't forget to add the milliampere. Another way that you can use to find the total current is simply using Ohm's law again. I total is equal to V total over R total. 9 over R total is 625. Nine divided by 625, 14.4 milliampere. Same value. Of course, you will get the same answer. Last step is to find the power. P1 is equal to I1 multiplied by V1. Here 9 times 0.9. 9 times 0. So P1 is equal to I1 times V1 from the table, 9 volt times 0.9 milliampere. 8.1 milliwatt, the unit. You can use the calculator. I2 times V2, 4.5 milliampere times 9. 4.5 times 9, 40.5. 40 again milliwatt, because I did not convert the current here. P3 is equal to I3 times V3. 9 milliampere times 9. 81 milliwatt. For the P total, either you add the three powers, P1 plus P2 plus P3, 8.1 plus 81 plus 40.5, 129.6 milliwatt, or I total times V total. I total is 14.4 milliampere times 9 volt. 14.4 times 9.